Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SNIT. Welcome to my new video. This video is regarding a revision on our second module, that is rolling. Okay. In this video, the portions to be covered are comparison between hot and cold working, principles of rolling, types of rolling mills, mechanics of flat rolling. Okay. Let us discuss the first topic, that is comparison between hot and cold working. Hot working. Hot working is done above recrystallization temperature, while cold working is done below the recrystallization temperature. Okay, second one, refinement of grains takes place in hot working, but in case of cold working, grain structure is distorted. Okay, that is, there is no refinement of grains in case of cold working. Third point, impurities and porosity are removed from metals after hot working. In case of cold working, impurities and porosity exist in metal after cold working. Okay. Fourth point, residual stresses are eliminated in case of hot working, but in case of cold working, residual stresses are not eliminated and have harmful effects. Okay. Fifth point, rapid oxidation or scaling of surfaces occurs, which results in poor surface finish in case of hot working. In case of cold working, no oxidation and hence good surface finish is obtained. And in case of next point, in case of hot working, close dimensional tolerance cannot be maintained, but in case of cold working, close dimensional tolerances can be obtained. Okay. Seventh point, that is, tooling and handling costs are more in case of hot working, but in case of cold working, tooling and handling costs are less. Then in case of hot working, mechanical properties such as toughness, ductility, elongation, etc. are improved. But in cold working, decreases elongation, reduction in area, hardness, tensile strength, fatigue strength, etc. are improved. Okay. The next topic is principles of rolling. Okay. Principles of rolling. The principles of rolling is that the metal is subjected to high compressive stress as a result of the friction between the rolls and the rolling process metal surface. Friction provides the required grip of rolls over the metal piece to draw the latter through them. The greater the coefficient of friction, more is the possible reduction. Okay. Rolling is of two types, hot and cold rolling. The crystals are elongated in the direction of rolling and they start to reform after leaving the zone of stress in hot rolling, but in cold rolling they retain substantially the shape given to them by the action of the rolls. Okay, this is the principle of rolling. Then types of rolling mills. There is classification of rolling mill is based on the number of rolling mills. First one, 2 high rolling mill, 3 high rolling mill, then 4 high rolling mill, planetary rolling mill, universal rolling mill, multi rolling mill, etc. First one, 2 high rolling mill. This mill has two rolls. You can see it in the diagram. Both rolls rotate in a constant direction, only one direction. That is one roller in clockwise and another one is anti-clockwise about the horizontal axis. The principal operation of this process is reduction of cross-sectional area of the stock means workpiece and increasing the length. This method is used for both the cold and hot rolling operations. Okay, that's two high rolling mill. 3 high rolling mill ആണ് അടുത്തത്. Here the upper and lower rolls are drive rolls and the middle roll rotates by friction. This middle roll is the backup roll. This type is used for rolling of two continuous passes in a rolling sequence without reversing the drive. After all the metal has passed through the bottom roll, I said the end of the metal is entered into the other set of rolls for the next pass. Okay, in this type, two metal pieces can be rolled in at a single time. Okay, 4-high rolling mill. It is essentially a 2-high rolling mill but small sized rolls. Okay, the other two rolls are the backup rolls for providing the necessary rigidity to the small rolls. There are two backup rolls which gives necessary rigidity to the working rolls, which is in contact with the workpiece. Okay. Then the next one is planetary rolling mill. For rolling arrangements requiring large reduction, a number of free rotating wheels instead of a single small roll are fixed to a large backup roll in the planetary rolling mill arrangement. Here, on the outer periphery of a backup roll, there are number of working rolls placed in a planetary arrangement. Okay. There are also, you can see, feed roll, planishing roll, etc. in this arrangement. Then mechanics of flat rolling. This is the diagram. In rolling, metal is formed through a pair of revolving rolls with plain or grooved barrels. The metal changes its shape gradually during the period of contact with the two rolls. From the figure, let T1, L1 and TI, LI, BI and TF, LF and BF be the initial and final thickness, lengths and breadths of the metal piece respectively. Let absolute draft del T is equal to TA minus TF in mm. Absolute elongation delta L is equal to LF minus LI in mm. Absolute spread delta B is equal to BF minus BI in mm. Okay, where TA and TF are the initial and final thickness of the metal piece. LF and LI are the initial, final and initial length of the workpiece, and BF and BI are the final and initial breadth of the workpiece. Okay. The spread depends upon the thickness and width of the job and is proportional to the draft. It increases with increase in roll diameter and coefficient of friction. Also, in course of hot rolling, spread increases with a fall in temperature of the metal. From the geometry in the figure, we have considering right angle triangle DCB and DCA. DCB and DCA, you can see in the diagram these two triangles. While considering these two triangles, DC, by the properties of triangle, DC by CB is equal to AC by DC. This implies DC square is equal to AC into CB. Also, BD is equal to root of DC square minus BC square. Okay. Hypotenuse square is equal to base square plus altitude square, which is equal to root of AC into CB. That is DC square is AC into CB. Therefore, BD is equal to root of AC into CB minus CB square. BC is equal to TI minus TF by 2. BC എന്ന് പറയുന്നത് initial thickness minus final thickness divided by 2 ആണ്, which is equal to del by 2. That is half thickness in half change in thickness. Therefore, BD is equal to root of 2R del by 2 minus del square by 4, which is equal to root of R del minus del square by 2. Because AC equal to 2R, BC equal to CB is equal to del by 2. Now DC is approximately equal to dB and del square by 4 is negligible because it is very small quantity. Therefore, del square by 4 can be neglected. And the chord DC is equal to root of R del, or del is equal to DC square by R. The above relationship, if R is constant, del can be more if DC is increased, and also if del is constant, then contact length will be more if R is more. Then angle of bite theta from the geometry. Cos theta is equal to 1 minus del by 2R. The minimum coefficient of friction necessary for unaided bite is equal to root of TI minus TF divided by R. Then the maximum Permissible angle of bite or contact depends upon the value mu, that is coefficient of friction, which in turn depends upon the following factors. That is, first one, materials of rolls, jaw being rolled, roughness of their surfaces, rolling temperature, etc. Process variables in rolling process. The main process variables in rolling process are diameter of the roll, angle of bite, speed of rolling, strength of metal work material, temperature, roll gap or draft, coefficient of friction, and dimensions of the sheet. Okay. Thank you for watching this video. Have a nice day.